You are welcome to the Scholar School. We establish our footprints on the sand of time, experience the difference.
Now we are discussing Avogadro's law, and I said Avogadro's, his full name is Amadeo Avogadro, and he started his research after the death of Gay-Lussac's. That was when he noticed the significance and importance of Gay-Lussac's law. Although Gay-Lussac's law failed to express decision state in John Dalton's atomic theory. So Avogadro, after working on the Gay-Lussac's law, he came up with a law that equal volume of all gases under the same condition of temperature and pressure contains the same number of molecules. What he's trying to say is that V is directly proportional to what? To N number of molecules. Now let's take another question. So what's the big question? The big question.
What will be the volume of
Ammonia produced. Now the problem now is it's not that big problem. Now if you are not giving this equation in the exam, it will be a problem if you don't know how to write the equation. Some questions they will just tell you that nitrogen and hydrogen react to produce ammonia, then they will give you the information, calculate. They will not write this information for you. Now the problem will now start coming from getting the right number of moles, balancing up. That is where the problem will start from. Now what will be the amount of ammonia produced? This is ammonia. So they are now asking us that what will be the volume of ammonia produced? From the question we are not giving volume of ammonia. So we will take this. Let's look at the question. 1 centimeter cube of nitrogen gave us 2 moles or 2 centimeter cube of ammonia. 2 centimeter cube of ammonia. Now you come here. 20 centimeter cube of nitrogen will give us how much? 20 centimeter cube of nitrogen will give us X. Right? Then you cross multiply. We have X equal to 20 times 2. That's 40 centimeter cube of ammonia. Are you with me? Or you can also calculate using hydrogen. Since we've been able to calculate the amount of hydrogen that was used there, 60 centimeter cube, you can also calculate using hydrogen. You can say 3 centimeter cube of hydrogen react and give us how many? 2 centimeter cube of NH3. Now, this is what you are going to use, not 90. Are you with me? Not 90, you are going to use 60. 60 centimeter cube of hydrogen gave us X. If you cross multiply, we have 3 times X. 3X equal to 60 times 2, 120, right? Then you divide both sides by the coefficient of X, which is 3. Our X is equal to what? 40 centimeter cube of NH3. That is for B. Now the question now goes on to ask us to calculate what? The C question.
what is the total volume of the mass mixture?
The total volume. Now the total volume of the mixture is the volume of the product formed. The total volume is the volume of the product formed and the volume of the excess gas. Yes, the volume of the excess gas. You are going to add them together. The volume of the product and the volume of the excess gas. So our C question, our C is equal to 40 centimeter cube plus 30 centimeter cube. That's equal to 70 centimeter cube. So some questions we just ask you to calculate the total volume of the gas formed. Now for you to calculate total volume of the gas formed, you have to calculate first the volume of the excess gas. After calculating the volume of the excess gas, then you calculate the volume of the product formed. Then after calculating the volume of the product form, you can now go on to calculate the total volume. What if? And that's what I'm saying, that some questions they will not even ask you that A and B. They will just ask you C direct. So that means you have to first calculate A and B. If you don't calculate A and B, you cannot get C. So some questions they will not ask you for A and B. They will just ask direct, calculate C.
And if you don't calculate A and B, you
cannot get C. Because they will not give you information that your residual gas is 30 centimeter and your product form, the volume of product form is 40. They will not give you. So they expect that you should calculate it yourself. Now let's take another question. Hydrogen plus oxygen to give water H2O. Now let's balance this equation. You have two moles of oxygen here.
But you can give us the reaction like this now, just balance the equation.
Yeah, mostly you might be giving the reaction balanced, but you have to check again if it is properly balanced. Let's take this question. What volume of oxygen will combine with 10 centimeter cube of hydrogen? What volume of oxygen will combine with 10 centimeter cube of hydrogen, comma, and how many centimeter cube of water vapor? And how many centimeter cube of water vapor will be produced under the same conditions of temperature and pressure? How many centimeter cube of water vapor will be produced under the same conditions of temperature and pressure? You should be able to attend that question, right? Now from here, 2 volumes of hydrogen react with how many volume of oxygen? 1 volume of oxygen to give how many moles? How many volume of 2 volume of water vapor. Now we were given from the question the centimeter cube of hydrogen, right? What's the centimeter cube? The volume of hydrogen given. 10 centimeter cube hydrogen. What about oxygen? We were not given. The question asked us to calculate for oxygen, right? Now, very simple. Let's calculate together. Here, 2 centimeter cube from the equation of hydrogen react with what? 1 centimeter cube of what? Oxygen. Are you with me? Now, 10 centimeter cube of hydrogen will give us what? 10 centimeter cube of hydrogen will give us X. Are you with me? Then you cross multiply. 2 times X, we have 2X equals to then divide both sides by the coefficient of 2 of X rather. X equal to 10 over 2, which is equal to what? 5 centimeter cube. So now we have 10 centimeter cube of hydrogen react with what? 5 centimeter cube of what? Of oxygen. This is the answer to the first question. 5 centimeter cube. We move to the next question. The next question says we should calculate the amount of water vapor produced in centimeter cube. What is the amount of water vapor produced in centimeter cube? Now, you can take this hydrogen to calculate the water vapor, or you take the other constituent, which is oxygen, to calculate the water vapor. Now, we are going to take the 2. Let's take for hydrogen. 2 moles of hydrogen. Now for the big question now. 2 centimeter cube of hydrogen gave us 2 centimeter cube of H2O. Are you with me? Now 10 centimeter cube of hydrogen will give us what? X. If you cross multiply, we have 2 times X, we have 2X equals to 10 times 2, 20. Our X is equal to what? 10 centimeter cube of what? H2O. This is for hydrogen. You have to get the same answer. Let's calculate for oxygen also. For oxygen, 1 centimeter cube of oxygen gave us 2 centimeter cube of what? H2O. Now, what we are going to use here is what we calculate in our first answer. 5 centimeter cube. 5 centimeter cube of oxygen react and give us X. First multiply, we have X equals to 5 times 2. 10 centimeter cube of H2O. Water vapor. The same thing. Yes, yes. This is just to show that you are correct. For your JAMB, you don't need to start doing this. Once you know what you are doing, once you be able to calculate and get 10 centimeter cube, that's your answer. No need to come here and start showing this. To confirm, from the beginning, you should be able to know. Now, if you are, just take a look at this logic. 2 centimeter cube here is giving us 1. It's just like half. So 10 centimeter cube, without even calculating, should give us 5. Because in JAMB, there's no time. There's no time. You don't even need to write self to solve this question. Once you look at it, 2 centimeter, 1 centimeter, and they give you 10 centimeter, you should know that your X is equal to 5. If they give you 20 centimeter cube, you should know that your X is 10 centimeter cube. No time to waste. Now, assuming we have 3 here, we have 3 and we are giving 1 centimeter cube here, and here is 30. You know that your X is what? 10. Because of time management. There's no time on it. There are some calculations that you don't even need to write sometimes. Just look at it. Less than 10 seconds, you are done. Go to the next. Do you know your question? Let's take this last question on Avogadro'S before we go to Dalton's law of partial pressure. The following reaction occurred. When 100 centimeter cube of carbon 2 oxide occurred. When 100 centimeter cube of carbon 2 oxide burnt in 70 centimeter cube of oxygen was burnt in 70 centimeter cube of oxygen. This is the reaction. Carbon 2 oxide, right? Plus oxygen will give us what? CO2. Now let's balance up. We have 3 here. 4. Balance. Are we there? Calculate the total volume of gas mixture. Calculate the total volume of gas mixture. Calculate the total volume of gas mixture. Open bracket, residual gas. Oh, we are lost. Let's start it. The following reaction occurred. Yeah. The following reaction occurred when 100 centimeter cube of carbon 2 oxide. When 100 centimeter cube of carbon 2 oxide was burnt in 70 centimeter cube of oxygen. Was burnt in 70 centimeter cube of oxygen. This is the equation of the reaction. This is carbon 2 plus oxygen to give carbon 4 oxide. Full stop. Calculate the total volume of a gas mixture. Calculate the total volume of gas mixture. Open bracket, residual gas. Find the residual gas. Close bracket. In the reaction vessel. Find the value of A in the reaction vessel. At the end of the reaction. At the end of the reaction. Assuming the temperature and pressure. assuming the temperature and pressure.
In the reaction
Calculate
version.
the
Calculate the total volume of gas mixture, open bracket, residual gas, close bracket, in the reaction vessel. Reaction vessel. At the end of the reaction, comma. At the end of the reaction, comma. Assuming the temperature and pressure. Assuming the temperature and pressure they adjusted to the initial values. They adjusted to the initial values. That's the question. Now, if you look at this question, the first question we did, I was telling you then that a question might be given and you'll be asked to calculate the total volume direct. They will now ask you to calculate volume of unused gas or excess gas, and they will now ask you to calculate volume of the product. There is no way you want to calculate total volume of the residual gas without first calculating the volume of the excess gas and the volume of the product. If you don't calculate these two, you cannot get the total volume. Are you with me? Now let's calculate. Now the data given, information given, info given. Another one. You were given 100 centimeter cube of what? Of CO2 and 70 centimeter cube of what? Of oxygen. Are you with me? Now the same way we solved for the first question, that's how we are going to solve for the second question also. We are going to look at the gas that is in excess, either carbon dioxide or oxygen. Are you with me? Now let's take carbon dioxide first. Now 2 centimeter cube of CO react with how many centimeter cube? 1 centimeter cube of oxygen. Are you with me? Now coming here, 100 centimeter cube of CO, we give how many centimeter cube? Are you with me? Here we have 2x equals to 100. Our x is equal to what? 50 centimeter cube. Right? Of what? Of oxygen. This is the first solving. Let's look at for oxygen now. For oxygen, 1 centimeter cube of oxygen reacts with 2 centimeter cube of CO. Right? Now, 70 centimeter cube of O2 will give us what? X. If you cross multiply, we have our X equal to 140 centimeter cube of CO. Equation 1 or solvings 1 and solvings 2. Which one are we making use of? Exactly, we are making use of 1 because 140 centimeter cube is greater than what we are giving. They are giving that 100 centimeter cube react, but here we calculate to get 140 centimeter cube. So we are going to be using this because here we were given that 70 centimeter cube was given react, but here 50 centimeter cube actually react. So it means we did not even use up to 70 centimeter cube, which means this 70 centimeter cube is in excess. What they gave us is in excess. They gave us 70 centimeter cube. We made use of 50 centimeter cube. Here we were given 100 centimeter cube. How come we get 140? How did we end up using 140 centimeter cube? Where did that 40 come from? So this is an error. But here we are given 100 centimeter cube. And we end up using 70 centimeter cube, and we end up using 50 centimeter cube. It means what we are given is even too much for what we need. So we are making use of this. So first of all, we've been able to calculate the volume of the gas in excess. Now, if a question asks you that what gas is in excess, the gas is in excess is what? Oxygen. And by how much? By how much? With the 70 centimeter cube that was given and 50 minus 50. We have 70 centimeter cube minus 50 centimeter cube. That is 20 centimeter cube. This is the volume of the excess, 20 centimeter cube. Are you with me? Now we are now going to calculate the volume of the product that was formed, which is carbon dioxide, CO2. Are you with me? So let's calculate the volume of carbon dioxide. Now we said if 2 moles or 2 centimeter cube of CO gave us 2 centimeter cube of CO2, right? Now what are we going to use? 100 centimeter cube of CO will give us X, right? So from here our X is equal to what? 100 centimeter cube. Do you understand? 100 times 2, 200. Divided by 2. I just write it direct. So our X here is 100 centimeter cube. Same way, if you try for oxygen, try using oxygen, you are going to get the same thing. 1 centimeter cube of oxygen gave us 2 centimeter cube. Now 50 centimeter cube. 50 centimeter cube will give us what? X. 50 times 2 will give you 100. That is your answer. So now going back to the question now that we should calculate the total volume of the residual gas. Now the total volume of the residual gas, as I said earlier, is the residual. Sorry, I said the residual. The excess and the volume of the product. So now the total volume of the residual gas now is what? 100 centimeter cube plus 20 centimeter cube. Total volume of residual gas. 100 centimeter cube plus 20 centimeter cube, and that is equal to 120 centimeter cube. That's that about Avogadro'S. Now let's move on to Dalton's law of partial pressure. Now going to Dalton's law of partial pressure, John Dalton, the originator of the atomic theory, he also studied the physical behavior of gases, and he came up with this law. So John Dalton, he also studied the physical behavior of gases, and his experiment leads to what we call Dalton's law of partial pressure. Now John Dalton states that the pressure exerted by a mixture of gases, John Dalton law of partial pressure states that the pressure exerted by a mixture of gases is equal to the sum of their partial pressure, provided that the gases do not react at that temperature. The partial pressure of a gas is the pressure. The partial pressure of a gas is the pressure it exerts when it is alone in a container at a given temperature. The total pressure of a particular gas or in a container, the total pressure in a container is equal to the number of pressure, partial pressure that is in that container. Let's say in a container we have mixture of gases. Now, what Dalton's law of partial pressure is trying to say is that the total pressure that will be exerted by that container is equal to the total number of partial pressure. And I said the partial pressure is the pressure of a gas in a container when it is alone. Now, total pressure will now be equal to the total number of partial pressure that is inside that container. That is what Dalton's law of partial pressure is trying to say. Now, it also says that this law also expresses that our total pressure is equal to the partial pressure of gas plus water vapor for the total pressure. We can also have the number of moles, total number of moles equals to
That's what I was
N1.
talking about. So I was talking this question before. So when they do them lines, when they want to combine the two,
You might be given some questions to calculate the mole fraction of the gas. So this is the formula. Now you might be asked to calculate the partial pressure in a gas. If you are asked to calculate partial pressure of gas 1, let's assume in that gas we have 3 constituents or 2 constituents of gas in that container. The partial pressure
For you to understand the concept of equation, I want you guys to do one study.
partial pressure of gas 1 is equal to
I'll be making reference to
P1
no, because
over P1 plus P2. Now if you are asked to calculate for the mole, it will be of gas 1, it will be N1 over N1 plus N2. To calculate for the partial pressure, instead of having the pressure 1, because this is what definitely we are looking for, it will be N, the number of moles, N1 over N1 plus N2 times the total pressure. So since we are looking for the partial pressure, we cannot be calculating for what we are needing, what we are looking for again. So it will be number of moles of gas 1 over number of moles of gas 1 plus number of moles of gas 2 times the total pressure. It looks confusing, right? But you start solving questions under it, you see that it's very simple. Now let's take just one question under this. A gaseous mixture containing 64 grams of oxygen. Containing 64 grams of oxygen. Containing 64 grams of oxygen. 64 grams of oxygen. Are you with me? And 70 grams of nitrogen. And 70 grams of nitrogen. 70 grams of nitrogen. Exert a pressure. Exert a total pressure. Exert a total pressure of 1.80 atm. Total pressure of 1.80 atm. 1.80 atm. Full stop. What is the partial pressure exerted by oxygen in the mixture? What is the partial pressure exerted by oxygen in the mixture? What is the partial pressure of oxygen exerted in the water in the mixture? Now, what is the partial pressure of oxygen exerted in the mixture? Now, with this just one question, we are going to make use of this formula that I'm giving today. Now, we are giving solution. We are giving 64 grams of oxygen, 70 grams of nitrogen. The first thing to do is to convert our mass to what? To mole, because we want to work with mole now. We are going to convert our mass to mole, and to convert, we all know that our mole is equal to what? Mass over molar mass. Don't forget that. This is the basics of chemistry, the foundation of chemistry. Our mole is equal to mass over molar mass. Now, our mass for oxygen, N oxygen, equals to 64 over, now the molar mass. Oxygen is 16, right? And it is diatomic molecule. 16 times 2. Don't forget it, 32. 64 divided by 32. 2?
no. 2.
2 mole. This is for oxygen. Now, for nitrogen, number of mole of nitrogen equal to, same thing, mass over molar mass. Our mass of nitrogen is what? 70 over. Nitrogen is also diatomic molecule, N2, and the relative molecular mass of nitrogen is 14. All these things you need to know it. They might not give you in your JAMB question. You need to know it. 14 times 2, 28. So here we have 28. If you divide this, our number of moles is equal to what? 70 divided by 28. That should be 2 point something. Two 2.5 exactly. 2.5 mole. Now, after calculating this, you will now calculate the total number of moles. Or instead of calculating it, we can just go direct. Now, partial pressure of what? Of oxygen. The question asks us to calculate partial pressure of oxygen. So we can say PP. Don't mind me, I like giving something acronyms. I like giving acronyms to something. PP is partial pressure. Partial pressure, PP. Partial pressure of O2 is equal to what? From the formula here. Number of moles of oxygen over number of moles of oxygen plus number of moles of nitrogen times PT, the total pressure. Are you with me? So here, what is the number of moles of oxygen? 2 moles. 2 moles over 2 plus of nitrogen 2.5 times our total pressure 1.80. 1.80. So here we have 2 over 4.5 times 1.80. Final answer. Our partial pressure for oxygen is 0.79 atm. 0.79 atm. So we are going to be stopping here for today. See you in our next class.